Hi, I hope everyone is doing great. In this series, we are solving chapter and exercises of FMS SC Gupta VK Kapoor, chapter number 17. Let's start with question number 17.18. Now, here we have to show that x bar is consistent and unbiased estimator of theta plus 1 by 2, where x belongs to uniform theta, theta plus 1. Let's do it. Please note that invariance property of MLE, consistency, sufficiency are very important from exam perspective. When we talk about R by N, that is basically the proportion of successes out of total number of trials in a binomial distribution. Now, question number 17.20. We have been given a Cauchy distribution with fx equals to 1 upon pi 1 plus x minus theta square. X ranges from minus infinity to infinity and theta is greater than 0. We have to show that sample mean x bar is not a consistent estimator of theta, and also sample median is a consistent estimator of theta and its asymptotic efficiency is 8 upon pi square. Now, first we note down the PDF of Cauchy distribution. To begin with, let's assume that the mean of the distribution exists at x equals to mu. If x bar, the sample mean, is taken as an estimator of mu, then the sampling distribution of x bar is given as 1 upon pi dx bar upon 1 plus x bar minus mu square, because in Cauchy's distribution, the distribution of x bar is same as the distribution of x. which implies it does not increase in accuracy with increasing n. Or we can say that expected value of x bar equals to mu, but variance of x bar is equal to variance of x does not tend to 0 as n tends to infinity. So x bar is not a consistent estimator of mu in this case. Now, by considering the symmetry, it is enough to show that the sample median is an unbiased estimate of the population mean, which of course is same as the population median. Therefore, expected value of median is equal to mu.
That's why I don't worry about the things that I don't see. Yeah. These days I don't worry about much. I think we should have some more fun. I still dream about the days when
Now,
we were young.
for large n, the sampling distribution of median is asymptotically normal and is given by
Memory lane isn't that too far away from our hearts, yeah. The ones we keep close, we should never let go. So tell me who you love, baby. Take a moment to unwind, fix yourself and realign yourself with the world, baby. Breathe slow, baby, yeah. Ooh. We should breathe slow, we should breathe slow, we should breathe slow. We should breathe slow, we should breathe slow, we should breathe slow. We should breathe slow, we should breathe slow, we should breathe slow. We should breathe slow,
the variance of sampling distribution of median tends to 0 as n tends to infinity. Hence, we can conclude that for Cauchy distribution, median is a consistent estimator of mu. Moving on to next question 17.21. It's a very easy question. We have been given T1 and T2 as consistent estimators of gamma theta, and we have to show that A1 T1 plus A2 T2, that is a linear combination of T1 and T2 such that A1 plus A2 equals to 1 is also consistent for gamma theta. Let's move on to the solution. Whenever we talk about any consistent estimator, we have to remember its properties. Now, expected value of Tn is equals to gamma theta equals to expected value of T2 and variance tends to 0. Which shows the linear combination is also a consistent estimator of gamma theta. Thank you so much for watching. Please don't forget to subscribe if you want to see more of these.